Hi everyone, it's Nono here, and we're gonna get started with one more week of the Machine Intelligence for Designer livestream, where we also do creative coding, podcasting, and many other things. For those of you who this is your first time watching, this is Nono Martinez Alonso, and I try to dedicate at least 1 hour every Thursday to machine learning, creative coding, and many other things. As always, I will ask you to like this video if you want to support the work that I'm doing here with the channel, and to subscribe if you want to be notified when I go live next or when I upload new videos. I would also ask those of you who are online to let me know if you can hear me and you can see me okay, as always. And I would invite everyone who's still not on Discord to join the community at none of the Mazda's Discord or going to that QR code up there. Last week, we took a deep dive at some papers and some of the most influential generative image-to-image translation networks. And you can go back to that video at None of the Masses Live/67. The latest podcast episode is getting a good reception online. I would ask you for questions for that or any previous episodes at gettingsimple.com/ask. I would appreciate if you send a voice note instead of just a text message, so we can use it on the podcast. And today I am going to show a few things that I've been doing during the week, a few posts, a few experiments, and we probably are going to take a look at some machine learning regression algorithms that I'm learning about. Among those are linear regression, logistic regression, softmax regression, rich regression, or lasso regression. I'm exploring terms like losses and regularization and optimizers, and many of the basic machine learning concepts that are not so easy to learn. I'm rereading the hands-on machine learning book that I've often recommended by Aurélien Geron. And if you're interested, let me know on the comments or in the chat and I'll put the link. And yeah, let's get coding, or let's get taking a look at the announcements and the things that I said I'm going to show. All right. So also, for those of you who are connecting online, please say hello on the chat and let us know where you're connecting from. It really helps knowing that there is humans behind the stream, let's say. And okay, so what can I show you today before we get started with the actual live stream content? I continue to publish online posts every week, so I'm trying to do that diligently at nono.ma. So this is my website, and I have things from crypto to tutorials on how to highlight your code with highlight.js, cooking ideas. These are the sketches posts that I put here that always go with a hand sketch and a little essay. And rendering a scatter plot with matplotlib, there's also how to do it. Later this week, there is another one that's going to come that is rendering a scatter plot with p5.js, and a few other posts that are already scheduled. Thoughts on live streaming and podcasting. I'm going to sort of paraphrase or read a bit of this, right? I'm using my weekly live stream slot, which is this, to learn more than to show things I already know. I'm trying to do this. I'm trying to read offline and study, but also to experiment and do things hands-on coding here. I've covered generative image-to-image translation networks last week, as you saw. We've also covered sketch vectorization, sentiment analysis, Bezier curves, and more, so you can go back to those live streams. I'm actively looking for people to help me editing some of those past videos and also editing some future tutorials. So if you're interested, you can email me at me@nono.ma, right? So that's my email. You can email me if you're interested in working with me on this. Also, I'm looking for people to edit podcasts and prepare content online. I'm not editing videos myself anymore until I find help for this job, and that's why you're not seeing too many videos being released on the channel other than podcast episodes and live streams. I want to focus on producing more content rather than editing, and hope to find help soon to get back at releasing edited clips regularly. As always, your questions are more than welcome, and I highly value everyone who's collaborating or contributing to the Discord community, especially those of you who are sending pointers to new publications and relevant machine learning projects, as well as feedback and comments on the topics I'm covering. Thanks a lot for being there, and I look forward to seeing you on the next stream, which is this. All right, I see on the chat Daniel Madrid. Hello, Daniel. He's saying hello from Colombia. Can you tell us a bit more what you're looking for watching this live stream? What are you looking to learn, or what's your area of expertise? What brought you here? Let's say. All right, so let's keep scrolling. This is just like a silly Git error. This is from last week's live stream. As I said, there were many things that we've covered there, and as always, you have chapters. So if you click any of these chapters, you're gonna be able to go to that part of the live stream. I know that live streams sometimes are super long, but this way you can jump directly to a specific section and watch that if that's what interests you. More on generative GANs, writing experiment, previous sketch. This is just an S3 error. I'm gonna jump. Oh, this is a little write-up when I discovered informative drawings. This is a network that is capable to map images to sketches and has like different losses to make sure that that task is correctly done. Sentiment analysis. This is something that we saw in Live 66. And today, I will say again, as a few weeks ago, we have some background noise from nearby construction. I hope it stops in the next 10 minutes. But if it doesn't, I'm sorry for that. I can't do anything. They're doing some construction work on the basically in my building below the floor of the studio. And as we've already talked about, Andrew Witz is the latest episode that has been released on the podcast. You can listen to it on YouTube or whatever you get your podcasts. Okay, so this is it for the blog. Let's take a look now at some of my P5 sketches. I am gonna open, well, I have the live folder here on the desktop. And I've been saving some images from my P5 experiments. All right. I'm gonna mute myself while the sound is going. Okay, so these are experiments that I've done that have to do with dynamically generating linear data. So it's related to this post of like how to draw points on a scatter plot, but this is linear data that I've generated. I'm gonna go back to this in a second when we go and take a look at regression as a topic. Okay, so we have some comments here from Daniel Madrid. I'm a backend developer. I'm learning how to optimize my code, and a lot of the techniques involve multiple models such as regression and classification. By the way, your website is dope. Thanks a lot. I mean, we do have a lot of stuff that I've made for the website to be the way it is, and this is like a really idiosyncratic project in which I've put a lot of hours and a lot of work. I mean, you can see how much care I've put on it because, yeah, I don't know. There is a lot, and I would love to rebuild many parts of it, but that's basically that's what I have been able to do so far. And yeah, we also created this one, which is, hasn't changed for a bit, but at least we have a custom player here, custom podcast player, and yeah, there's more stuff that is coming in the near future. So thanks for that comment. And yeah, so your techniques involve multiple models such as regression and classification. Can you tell us a bit more what type of models you're working with, Daniel? Okay, so another experiment that I've done, and again, I'm gonna show these things because there's a lot of noise. All right, I'm gonna ignore the day's background noise if I can until unless they're hammering a wall or something. This here is a really simple experiment on using like a linear equation that we got from Handsome Machine Learning, the Handsome Machine Learning book, and plotting that as a scatter plot on Colab with Matplotlib and exporting that as a PNG. So that is the post that I was referring to from the blog. So you can see that here. Um, yeah, and actually, let me edit that and link to this. I'm gonna link to the blog post from the Colab notebook. All right, so I have here. Here's how to generate. Okay, so I just added this link here. So here's the Colab notebook, and you can basically open that on your machine. And if you run this, so let's execute this block. Let me move this part. It just regenerates this thing, right? And if we refresh here, you can see that the image is in here. So to remove this linear regression text, you just need to comment this part here and regenerate. So why do we want to generate linear data? This is a really simple way to generate random linear data that we can later use as a data set to train a regression classifier. So let's take a look at, I was trying to see the examples of the book I have here. All right, so let's see where this equation actually is. Let me actually take a look at, I have the PDF somewhere. Yeah, okay, so we actually got this from here. So this is the equation that I've got, right? So basically this is what I'm defining there. Maybe we can credit this here. So okay, so how do we do this? All right, so all right, so I just added this here. Okay. So from the book, we're just gonna use the examples of the book just to make sure that we can run them, right? So now let's compute theta using the normal equation. We will use the inverse function from NumPy's linear algebra model, NP linear algebra, to compute the inverse of a matrix, and the dot method for matrix multiplication. All right. Let's actually not just copy the code. Let's actually just type it. Okay, had, I just remembered I have a feature on my website in which I can activate something here on the header. So if I zoom into here, let me see where this is. All right, so I'm just trying to go through this example. I continue muted today because of the background noise. So let's see, while there is no noise, what is happening here. So let's say we just have 15 points here and we run all. All right, so we have those points and we're adding this one. Let's say we add this. Okay, we can add many ones. All right, so we're doing that, and now we have that x underscore b. We can get our theta best 4 and 2.55. So what you can see is that we do have this equation here, right? So we have this equation and we have these two parameters, 3 and 4. This is our linear equation, right? And what we're trying to do is learn this 4 and this 3, because that is basically the linear function that we're trying to get. Because that way we can input new x points and plot them on the graph. So we can use this normal function, it seems. So we're adding one and the 0 component of each instance, and then we get the best of the this is we'll use the im function to compute the inverse of a matrix, and the dot method for matrix multiplication. This is the dot method for multiplication, blah blah blah. Okay. Okay, so here we use inv to compute the inverse of a matrix, and dot for matrix multiplication. Hi, so DBS. Oh, wait 1 sec. Am I? Okay, hi, so DBS. I was muted before because of the background sound, which you might hear. How's everything going? What are you up to? Can you tell us what are you? Have you been looking at anything related to coding or machine learning lately? I'm glad that you can join us. I know it gets late in China. All right, so let's actually play a bit with this. So if I have a, let's say I have a equals, we can do here 1 2 3 and then 4 5 6, and then we have b equals 1 1 1 1 1 1. All right, so can we use NP linear algebra and then do dot t? Okay, c, what is c? Okay, maybe before we do that, let's actually go here and do, let's look at the documentation actually. Translates slice objects to concatenation along the second axis. Okay, so it transposes the matrix, I guess. So if we do here 1, 2, 3, and 4, 5, 6, class object. 1, 2. All right. So it actually makes a matrix with those rows vertically. So we don't have to do it. All right. So I guess then what we want to do here is something like this. All right. So we do have these two matrices. You know, we could put here, I don't know, let's say 1, 2, 3, 3, 2, 1. That way it makes a bit more sense, right? Okay, so if we do MP linear algebra dot and we get, let's say if we can get can we get a and b? Let me see what this function gets. Dot dot. Okay, I guess let's try to get first this. Okay, so this is the transposing the matrix, right? So if we do t, can we do that? Okay, so if we do transpose the matrix twice, we get the same thing. So I believe we could do here transpose dot. Okay, so we could do here transpose dot b. Let's see what we get. B linear algebra. Wait one sec. Let me. Okay, that's to get the inverse. So we don't need to do that right now. Inverse. All right. So let me see. Let's not remove this. So we get this, and I guess if we refresh a bit on matrices, let's see if we know what we're doing. So how was this? So is it this row? Let's see. One by one. So one by one. So 1 by 2 plus 3 plus no 4 numbers. Let's actually just look it up. So matrix dot product. You see, for me this is a refresher. Yeah, currently, so DBS says currently trying to understand reinforcement learning is fascinating. Have you seen DALL 2? Man, I haven't. Well, this is crazy. Okay, this is a bit of a distraction, but this is crazy. Okay, let's actually add a marker here. Let's join the open beta. Right, we're on the wait list. Read the announcement. I think this is crazy. What? Whoa. This is impressive. Man.
Have you ever seen a polar bear playing bass? Or a robot painted like a Picasso? Didn't think so. DALL-E 2 is a new AI system from OpenAI that can take simple text descriptions like a koala dunking a basketball and turn them into photorealistic images that have never existed before. DALL-E 2 can also realistically edit and retouch photos. Based on a simple natural language description, it can fill in or replace part of an image with AI-generated imagery that blends seamlessly with the original. It's called inpainting. In January 2021, OpenAI introduced DALL-E, a system that could generate images from text, like this avocado armchair. DALL-E 2 takes the technology even further with higher resolution, greater comprehension, and new capabilities, like inpainting. It can even start with an image as an input and create variations with different angles and styles. DALL-E was created by training a neural network on images and their text descriptions. Through deep learning, it not only understands individual objects, like koala bears and motorcycles, but learns from relationships between objects. And when you ask DALL-E for an image of a koala bear riding a motorcycle, it knows how to create that or anything else with a relationship to another object or action. The DALL-E research has 3 main outcomes. First, it can help people express themselves visually in ways they may not have been able to before. Second, an AI-generated image can tell us a lot about whether the system understands us or is just repeating what it's been taught. Third, DALL-E helps humans understand how AI systems see and understand our world. This is a critical part of developing AI that's useful and safe. The technology is constantly evolving, and DALL-E 2 has limitations. If it's taught with images that are incorrectly labeled, like a plane labeled car, and a user tries to generate a car, DALL-E may create a plane. It's like talking to a person who learned the wrong word for something. DALL-E can also be limited by gaps in its training. If you type baboon and DALL-E has learned what a baboon is through images and accurate labels, it will generate a lot of great baboons. But if you type howler monkey and it hasn't learned what a howler monkey is, DALL-E will give you its best idea of what it thinks it could be, like a howling monkey. What's exciting about the approach used to train DALL-E is that it can take what it learned from a variety of other labeled images and then apply it to a new image. Given a picture of a monkey, DALL-E can infer what it would look like doing something it's never done before, like paying its taxes while wearing a funny hat. DALL-E is an example of how imaginative humans and clever systems can work together to make new things, amplifying our creative potential.
Oof, that's crazy. Really, at some point, I don't understand what's the point of learning machine learning if these things are gonna be there really soon. But anyhow, that's really exciting. Thanks for sharing, Sodivius. Yeah, this is crazy. All right, we were gonna look down at the world. Just we were gonna look at the how to multiply 2 matrices together, the dot product, right? Just really quickly. So we have A and we have B. The dot product. Okay, so if we maybe get, let's take a look. If we maybe get something like this, so if we get 1 second, so we can get this. Well, let's say we get this. So we get that and that. Maybe the opposite. Right, so this is what we saw before, right? So that's the dot product. One by 4 plus 2 by 5 by 3 by 6, 32. So what are we getting here? Okay, so that's 1, 2, 3, 4, 5, 6. 5, 6. And that yields 32. All right, so that is this example here. So if we look at this logic, so we have 1, 2, 3, 4. How do we get those numbers? Blah blah blah. The dot product, matrix multiplication. Okay. All right. So in here, because we have 4 lines, so we can do Can we do this? It's the same, right? Aha. All right, so this is actually, all right, so this would be one. Let's try to do it here really quickly. So this would be 1 by, so I'm doing these 3 by this, and that one, these 3 by this, and that one. Let's just see really quick. So 1 by 1 plus 2 plus by 1, 3, 1, comma, and then 1 by 3. Oh, this is actually 2, 3 by 3 plus 2 plus 2 plus 3 plus by 1. All right, so we get so we print this. All right, so that's the way it works, and we can actually do it with like 4 by 1 plus 5 by 2 by 6 by 3, and then we can keep going. Actually, we can just get this one and say 4, 5, 6. All right, and we're getting the same thing. Okay, so that's how the dot product is working, and let's now go to see what, well, let's see what the inverse is actually doing. So this function. So now that we can see what this is doing for us, AB dot, so we can do this AB dot and get the inverse. All right, so from the book, this gives us the function from NumPy's linear algebra model to compute the inverse of a matrix. I guess. All right, so 1 by 14. Nope. Okay, so let's do here. Let's actually make another block. In PC, and we're gonna do 1, 2, 3. 1, 2, 3, 4. Okay. Minus 2, 1, 1.5 minus 0.5. Okay, here's the function. So this is mathisfun.com, and we would do, let's actually just call this MA because we're gonna do A, B, C, and D. We're gonna do 1, 2, 3, and 4. A, B, C, D, and apparently this same inverse matrix. All right, so this same inverse matrix we should be able to get if we do 1 divided by, and here we got AD. So let's put this in shape. AD minus BC. And then multiplied by the matrix DA minus C minus B. How we do that? Not sure if I can do this. Well, let's first see what that number is. AD. Oh, wait 1 second. All right. And let's try to print here another MPC. And then instead of this, we're going to try to do here minus D. So D minus B minus C A. All right, so this seems like it's good. We just need to multiply by 0.5, and I'm not sure if I can do this. All right, so I guess I'll do multiply by this. Okay, so this is like the inverse. Inverse of a matrix, and we can cite this thing here. And this is, well, not exactly this part. We could remove this one. But this is how to calculate the dot product. All right, so we've done that. Now that we understand this process, so let's try to let's put a text block here. Let's do a bit of manual math to understand NumPy's linear algebra utilities to calculate the dot product of two matrices and the inverse of a matrix. Dot and the inverse of a matrix, which is inv. All right, so now that we know that, we can go back to our problem. We do have here our equations. Let's now go back to our initial problem and try to use this method to calculate our parameters. All right, so we have this information here, and what the book is telling us is that we need to add the ones to the first row that we have here. and then calculate the inverse. All right, so with this in mind, just with 15 points, so let's put here theta best. We get 3 and 3.25. Let's say we put more points. 3 and 4, let's put 20,000 points. Okay, we get 3 and 4. I don't know if we can. All right, we keep getting closer if we add more points there, right? So we're at 4 and 3. But if we just get, let's say, 100 points, we're not as close all the time, right? Okay, so that's what the book tells us. Now you can make predictions, blah, blah, blah. So we can say now, now we can make predictions, and we can say, okay, so my new X is an NumPy array of like 0 and 2. And then we get here new B, MPC, MP1s, 2, 1, X new. This does the same, so add X0 equals 1 to each instance. And we do here Y, so Y predict equals X new B dot theta best, right? So this is our function, and we put here Y predict. Cannot interpret 1 as data type. MP1s. All right, so the data type is, so the shape is actually that. Right, 9.26 and 9.66. These are points on a linear scatter plot, right? So R minus PLT plot X, Y, B. All right, so this is our line, and I'm not sure where all those blues are coming from. I think that might be from the previous plot, right? So these points here maybe. X and Y, let me see. X new, Y predict. I wonder where the points are coming from. Okay, here we have 100 points actually. Okay, so we do 200. Okay, so it's actually predicting for those. So let's say we get different points and plot this. So for each algorithm, we're getting slightly different curve. And you can see that if we do this print, well, it's it's almost the same. Yeah, okay. So that's our prediction, and we are okay. So yeah, that's what we thought we were gonna get, right? Cool. So that is our prediction, and no matter how many times we do it, we have the same points right now. Okay. And performing linear regression using Sci-Kit Learn is quite simple. All right, so this is, we've seen how to do this manually. Like this is the normal equation. Um, and this is how to do that, right? But if we do linear regression with Sci-Kit Learn, and I'm gonna go soon because we've been going for an hour. All right, so this is how to do it with Sci-Kit Learn. So we can actually do it in here with from sklearn, and we're using Colab, so this comes by default, but you'll have to install these dependencies if you're not using Colab. You'll have to install Sci-Kit Learn. Import linear regression. All right, and we'll do linear regression equals linear regression. So let me put this up so you can see. And that's it. So we have a linear regression model here, linear regression. And what we have to do now is just fit our data. So we fit x and y, linear regression, intercept, linear regression coefficient. All right, let's see. Has no attribute, coef. Coef underscore. All right. 4 and 3, right? So it's fit our data, and we could now say, so let's print this out, and let's print the linear regression predict x new. Right, so it's predicting 4 and 9. And all right, that makes sense. We could actually, I don't know, generate more data points here. So 500, right? That gets closer to 4 and 3, 3.9 and 10. The linear regression class is based on the SciPy linear algebra LSTSK function. The name stands for least squares, which you could call directly. Right. Regression class is based on SciPy's least squares function, which could be called directly. Theta best, residuals, and rank, and S, MP, linear algebra, least squares, X, B, Y, arcond. Right, let's make this a bit smaller. Theta best. Right, so this is prediction. This function computes theta hat, where is the pseudo inverse of x, specifically Munro's-Pervos inverse. I don't understand what that is. You can use MP linear algebra PIM to compute the pseudo inverse directly. and P linear algebra P inverse xb dot y. Right, and yet another way of calculating the same thing. The zero inverse itself is computed using a standard matrix factorization technique called singular value decomposition, SVD, that can decompose the training set matrix X into the matrix multiplication of three matrices. See, the zero inverse is computed this way. This is more efficient than computing the normal equation. Okay, let's put this note here. All right, so computational complexity, gradient descent. Okay, so another day we'll try to look at gradient descent. I personally haven't looked at this chapter yet, but some of the things that I wanted to look at here, probably I need to take a look, a better look offline. Let's see. Yeah, here, regularized linear models. So we're going to take a look at some other linear regression models with regularization, and we'll try to understand what that is and how that influences what we did today, right? So this is the notebook for linear regression. So we are going to share that today. Copy link. I'm going to put the links on Discord. And we're going to go. All right, so to not keep you hanging, I'm going to wrap it up. So I'm going to share that notebook now. I'm going to open the slides here and I'll say, yeah, so thanks a lot for being there, for watching. Leave a comment if you enjoyed the video and make sure to like it to support the work that I'm doing here with the channel, and to subscribe if you want to get a notification when I go live next or when I upload new videos. We're getting many videos ready to be edited. If you are, if you would be willing to work with me and edit videos, reach out. You can email me at me@nono.ma. And yeah, let's get the conversation going. All right, and don't forget to join the community at nono.ma's Discord. Thanks. So thanks everyone a lot for watching, and I will see you next week. Bye. Well, actually, I'm thinking maybe next week we don't have a live stream on Thursday. I'm not sure if I'm gonna be able to fill in another day, but we'll see. I'll say it on the Discord channel. Bye. I'm gonna try to record a cover for the. I'm gonna try to record a cover for the thingy for the cover of the video now that we're here. So let me actually put this camera, put a color, and I think this is it, right? Okay, bye. I think that will do it. Have a nice day.